This video is going to be lesson 1 of pre-calculus, and lesson 1 is all of the methods of factoring that you need to know in order to be able to do calculus. So in Math 10, 20, and 30, we only looked at 4 methods of factoring. Factoring by GCF, by inspection, by decomposition, and a difference of squares. In calculus, there's 2 additional methods of factoring that we need to know. It's going to be the sum and difference of cubes, which will be in this lesson, and rational exponents, which will also be in this lesson. So let's actually start by factoring a difference of squares. So a difference of squares, when we have 2 terms separated by a minus, each of these terms can be square rooted. So if I say to factor x squared minus y squared, the 2 factors would be x minus y and x plus y. So let's look at this first example, factor x squared minus 9. So I know that the square root of x squared is x, and I know that the square root of 9 is 3. One of my factors gets a positive and one of my factors gets a negative. Now, the reason why we factor is because if I was to graph this function, factoring gives us x-intercepts. So you need to be able to look at this and say, okay, this would be a parabola, it would be a quadratic function. The y-intercept of this would be negative 9, but the x-intercepts of the function would be plus or minus 3. Now, let's look at this example. We wouldn't have given you this in Math 10, 20, or 30, but in calculus, I could give this to you because this could still be factored by a difference of squares. So what we would do is we would say, okay, I've got 2 terms separated by a minus, so it will be a difference of squares. The square root of x squared is x, and the square root of 5 is just going to be root 5, plus or minus. Now, the reason why I want to know this is because this graph would have 2 x-intercepts. It would have a y-intercept at negative 5, but the x-intercepts of this function would be plus or minus root 5. Now, we don't have a calculator to see where the square root of 5 is, so I just want you to think about this. We know that the square root of 4 is 2, and I know that the square root of 9 is 3. So that means that the square root of 5 would be a number between 2 and 3, and it would be much closer to 2 than it would be to 3. And the square root of 5, it's approximately equal to 2.2. So this function would have 2 x-intercepts. The x-intercepts would be plus or minus root 5. As decimals, root 5 is right around 2.2. This one here would be a difference of squares again. And it would be x minus the square root of 20 and x plus the square root of 20. And then you would want to rewrite, reduce the square root of 20. So the square root of 20 is 2 and 10, 2 and 5. So the square root of 20 is going to be equal to 2 root 5. So square root of 20 reduced would be 2 root 5. So this would be x minus 2 root 5 and x plus 2 root 5. Okay. This next one, 25x squared minus 8. Again, difference of squares. We would get 5x minus the square root of 8, and we would get 5x plus the square root of 8. So again, square root of 25x squared is 5x, and then we would have the square root of 8. Now the square root of 8 is going to be 2 root 2. So this factored would be 5x minus 2 root 2, and this guy would be 5x plus 2 root 2. Okay. This one right here, it will be a difference of squares, but before it's a difference of squares, you need to look at this and you need to say there's something else that we could factor out before we do a difference of squares. So we're going to factor first by GCF, and then we'll do a difference of squares. So the GCF, x to the 3 and x to the 1, you always factor out the lowest power of x. So I could factor out an x to the 1. I've got y to the 1 and y to the 3. Again, I could factor out y to the 1. So the GCF is xy. The GCF always goes in front, and after you carry out the division, it goes within your bracket. So x cubed divided by x will give me x squared, and the y's will cancel, minus x's will cancel, and we'll get y to the 3 divided by y to the 1, which will leave me with y squared. The GCF is a factor, x squared minus 2 is a factor, sorry, x squared minus y squared is a factor. This could be further factored by a difference of squares. So this factored would be x minus y, x plus y. And then don't forget your GCF in front. Okay, so that would be the fully factored form of that function. This one here, x to the 8 minus y to the 8. So first we're going to factor, again, by a difference of squares. So the square root of each of these. So just think about what the square root of x to the 8 is. So x to the 8 is 8x's. And the index is a 2. So I'm going to circle my pairs. And for each pair, you're going to cross it out, and you would take out an x. So I take out another x, and another x. So the square root of x to the 8 is x to the 4. Square root of y to the 8 is y to the 4. From here, one of these factors could be further factored. So this factor would be a difference of squares. So the square root of x to the 4 is x squared. The square root of y to the 4 is y squared. One gets a plus and one gets a minus. And then I'll bring this down. And then from here, I want you to look at that answer because within there, one of those factors could be further factored. So the one that could be further factored would be, there's a difference of squares right here. These can't be difference of squares because remember, it's got to be a difference. So we need a minus in order for it to be difference of squares. So this could be factored to x minus y, x plus y. And then I had x to the 4 plus y to the 4. And then I have x squared plus y squared. Okay? Okay, so that, for the most part, should be a review, difference of squares. What's new for calculus is sum and difference of cubes. So for sum and difference of cubes, you're going to have two numbers that each of these numbers are going to be perfect cubes, and they're either going to be added together, so that would be a sum of cubes. This would be your formula for a sum of cubes. Or you're going to have two perfect cubes that are being subtracted. This would be the difference of cubes, and that would be your formula for difference of cubes. You will be given these two formulas on any quizzes or exams. I would provide you with the sum or difference of cubes formula. Okay, so this one here, x cubed minus y cubed. I can't pull out a GCF, so this is going to be a difference of cubes. So how we want to do difference of cubes, because remember this is going to be new, is you want to figure out what is A and what is B, okay? So A is going to be the cube root of this. So A is going to be the cube root of 8x cubed. Because if I could figure out what A is, the formula for factoring a difference of cubes is going to be A minus B. So A is going to be the cube root of this first term. Now remember that 8 is 2 and 4, 2 and 2. So the cube root of 8 is simply 2. And the cube root of x cubed is x. So A is equal to 2x. Now we need to calculate what B is. So B is going to be the cube root of this term. Okay, so we've got what A is. Now we need to calculate what B is. So B is the cube root of 125 y cubed. So 125, if you divide 125 by 5, you're going to get 25. 25 by 5 is 5. So the cube root of 125 is 5. Cube root of y cubed is y. So now that I know A and that I know B, you're going to plug it into the difference of cubes formula. So the first factor is going to be A minus B. So A minus B. Then the second factor is going to be A squared. So here's A. If I was to square this, I would get 4x squared. Then it's going to be a plus A times B. So A times B, 2 times 5 is 10xy, would be AB, plus B squared. So this was B. If I square this, distribute the 2 on the y and the 5, I will get plus 25y squared. And that is your answer. And that's how you factor a difference of cubes. Okay, let's do this one. So two terms, they're being added together. This is a perfect cube and one is actually a perfect cube. So again, what you need to do is you need to identify what A is and you need to identify what B is. So A is going to be the cube root of this first term. Okay, the cube root of 64 is one that you will eventually know, but the cube root of 64, if I divided this by 2, I would get 32. Divide this by 2, I'd get 16. Divide this by 2, I'd get 8. Divide this by 2, I'd get 4. And then if I, divide that by 2 and I'd get 2. So the cube root of 64 is going to be 2 times 2, which is 4. So cube root of 64 is 4. Cube root of x cubed is x. So that's my A term, okay? Now we need to calculate the B term, and B is just the cube root of 1. Now the cube root of 1 is 1. So the cube root of this term, cube root of 1 is 1. Okay, this is a sum of cubes. So we're going to use our sum of cubes formula. A plus B is my first factor. So A is 4x plus 1. And then my second factor is A squared. If I square 4x and I square it, this 2 will go on the x and on the 4, so that would be 16x squared. Minus AB, 4x times 1 will give me minus 4x. And then we do plus b squared. So plus 1 squared is 1. And that would be your difference of cubes factored. Okay. What I would do is I would pause the video and try this one on your own. And then you could unpause it and see if you get the right answer. So this is going to be a sum of cubes. So we need to identify what A is. A is going to be the cube root of this first term. Cube root of 8 is 2. Cube root of x squared is x. B is going to be the cube root of this term. Cube root of 27 is 3. And the cube root of y to the 6 is y squared, right? So remember, visualize 6 y's underneath your radical, and then you circle groups of 3, and you'd have 2 groups of 3. So then this is a sum of cubes. A sum of cubes, the first factor is a plus b. So it'd be 2x plus 3y squared. And then the second factor is going to be a squared. So this guy squared would give me 4x squared. Plus, it's a sum of cubes, so sum of cubes actually has a minus here. Minus a times b. 2x times 3y squared would be 6xy squared. And then it would be plus b squared. So plus, imagine this squared, and it would be 9y to the 4. And that would be factoring a sum of cubes would be your answer. What I would do is there's going to be a second part to this lesson, but before I do that second part, or before you do it, you should do in the homework, you're going to have these 6 questions in the textbook. Now, a lot of you, if you're doing this at home, you won't have your textbook. So this is page 3 from the textbook, and you want to do 1, B, E, and G. So looking at these ones are like 1B is an inspection question, 1E is a decomposition question, and 1G is going to be a GCF and then an inspection. And then 2A, it looks like it's a factoring by difference of squares. 2E will be a difference of cubes. And then you figure out what F will be. This will be a sum of cubes. Okay? When you're done that, you can go to this part of the video. All right, let's now factor rational expressions, rational exponents. So factoring rational exponents, what's going to happen here, if you look at all of my exponents, they're going to be fractions. How do we factor out fractions? So what we do is we're essentially factoring out a GCF, and the rule is you always factor out the variable with the smallest exponent. So 5 over 2 is 2.5, 3 over 2 is 1.5, and 1 over 2 is 0.5. So the smallest exponent would be a to the 1/2. So first we're going to factor out a GCF, and the GCF is going to be the variable a with the smallest exponent, which is a to the 1/2. So I'm going to factor out by a GCF. The GCF, remember, always gets written in front of your bracket, and then the answer will go in the bracket. So bring down the 2. Now remember, we don't have calculators, so we want to be able to just do this on a separate sheet of paper off to the side. So it's 5 over 2 minus 1/2. So 5 over 2 minus 1/2 will give me 4 over 2, and that will give me 2. So what I'll be left with is bring down that 2, and then the a would be a squared. So we'd have 2a squared plus. Now we have to subtract 3 over 2 minus 1/2. So 3 over 2 minus 1/2 is going to be 2 over 2, which is 1. So we're going to have a to the 1 minus, this will cancel, and we'll have a 3 there. Then you're going to look at this, and you're going to say, can I further factor this? Because often you will be able to further factor this. So this is a trinomial that we could factor by decomposition. So that was a PSA 2 or a decomposition question. So let's just quickly, we'll do one review of factoring by decomposition. So I'm looking for 2 numbers that give me a product of -6 and a sum of 1. So that would be 2 and 3. And if I want the 1 to be positive, it would be -2 and +3. Okay, so decomposition, I'm going to decompose 1a. How do I get 1a based on this answer? -2a plus 3a. That's how you decompose and get 1a. So -2a plus 3a will give you 1a. Bring down that -3, bring down that 2a squared. You're going to have 4 terms. You're going to split those 4 terms in half, and you're going to group factor. Okay, so 2a squared plus 1a minus 3, that factored would be a minus 1 and 2a plus 3. Then don't forget to bring out your GCF to bring that down and to include that in your answer. And we would have this as my answer. And then what I'm going to do is your textbook for this lesson might like say that's your final answer, but remember, we could write that as a radical. So yes, for this lesson, I would accept that as an answer, uh, but maybe even better would be this as my factored answer. Okay. The reason why the book will allow you to stop with fractions in the exponent here is because the original question had rational exponents, so the book will allow your answer to have a rational exponent. Okay, let's look at this one. 5a to the 3 over 2 minus 20a to the negative 1/2. So what you need to see is you need to see that this is a GCF. Between a 5 and a 20, I could take out a 5. So I could factor out a 5. And then a is common to both of these, and you always want to pull out the a with the smallest exponent. So 3 over 2 is 1.5. This is negative 0.5. So I'm going to pull out a to the negative 1/2. I'm going to factor that out. So remember, your GCF goes in front of your bracket, answer in the bracket. So 5 divided by 5 cancels, or it gives you a 1. And then I'm going to have 3 over 2 minus this. Two negatives will give you a positive, and that's going to give you us 4 over 2. 4 over 2 reduces to 2. So it would be a squared minus 20 divided by 5 is 4. And then a to the negative 1/2 over a to the negative 1/2. If you did negative 1/2 minus negative 1/2, you'd get a to the 0, which is 1. So this will cancel. And we're going to get minus 4. Okay, from here, we have a difference of squares. So hopefully you see that that becomes a minus 2 and a plus 2. Again, your book for this lesson will allow you to stop and write that as your answer. However, later on, we know we're going to make that positive. So I'm going to keep the 5 where it is. I'm going to reciprocate the a and bring it down to the denominator, and I'll have a to the 1/2. Then I will have a minus 2 and a plus 2. And then the last thing, hopefully you see, is that this could be written as the square root of a as an answer. Okay? All right, let's look at number 8. So I have a bracket to the power of 5 over 2, and this is the exact same bracket, x plus 2, x plus 2 to the 3 over 2. So you could just imagine, for example, that this would be like a to the 5 over 2 minus 3a to the 3 over 2. So what my GCF is going to be is, because that bracket is common to each term, I could factor out this bracket, this x plus 2. Now you factor out the smallest exponent. So 5 over 2 is 2.5, 3 over 2 is 1.5. You factor out the smallest exponent, which is going to be the 3 over 2. Okay, so your factor, your GCF, goes in front of your bracket, and your answer is going to go in the bracket. So this is going to cancel, right? X plus 2 to the 3 over 2 over x plus 2 to the 3 over 2 will cancel. What we will have over here is we are going to subtract the exponents. So we're going to have x plus 2, and we need to figure out to what power this will be. So it's going to be 5 over 2 minus 3 over 2. And that will give me 2 over 2, which is 1, minus the 3, because this will cancel. Okay, this bracket is just simply x plus 2 minus 3, and then that could be cleaned up to be x minus 1. Now remember that this I'm going to bring down, and I'm going to bring this down as well. Okay, so again, when you look at the textbook solutions, that would be the answer. However, later on, I'm going to say, I don't want you to leave this with a rational exponent. So we're going to write this as a radical, right? So remember the root is the 2. So underneath a radical sign, I'm going to put x plus 2. And it's going to be to the power of 3. And the index is a 2. But again, you don't need that to write the square root of that. So it would be the square root of x plus 2 to the power of 3. And then that is going to be times x minus 1. So later on in the course, this would be the answer you would give. Right now, it's fine to give that as your answer. Okay, we have a couple more questions, and then we will be done this lesson. I think we have got 4 left. All right, so again, x plus 4, x plus 4. We're going to be factoring out an x plus 4. Each of the terms has x plus 4. You want to factor out the x plus 4 with the smallest exponent, which is going to be this one right here. So I'm going to factor out an x plus 4 to the negative 1/2. Okay, whatever your GCF is goes in front of your bracket. Answer goes in the bracket. Now this will cancel on this side, and I'm going to have like a minus 4 at the end. But let's figure out what we would have here. So I would have this bracket, and I need to figure out what the new exponent on the bracket will be. So x plus 4 to what power? So it's going to be 7 over 2 minus negative 1 over 2. 2 negatives will give you a positive, and that will give you 8 over 2, which is 4. Okay, and then minus 4. Now, if you look at this, what I hope you would see is this can actually be further factored, and this is a difference of squares. So the square root of this would be x plus 4 squared. The square root of 4 is 2. 1 gets a plus and 1 gets a minus. And then I have this x plus 4 to the negative 1 over 2. Okay. From here, could I clean this up? So from here, what we're going to do is let's expand this and add 2. In this factor, we're going to expand this and subtract 2. So remember when you have a binomial squared, you got to write that binomial twice. Oops. So it would be x plus 4 times x plus 4. And then that is going to be plus 2. So let's see what that would give us. So it would give me x squared. Then it would give me plus 4x plus 4x. So x squared plus 8x plus 16. And then there was a plus 2. This one, again, when you expand this, so I've got it written up here, we would have x squared. So again, x plus 4, x plus 4, and then we're going to have a minus 2. So x times x is x squared plus 4x plus 4x. That will give me plus 8x plus 16 minus 2. Okay, each of these could be cleaned up. So this would be x squared plus 8x plus 18. This one would be x squared plus 8x plus 14. And then this, I'm going to write it in the denominator to make it positive. And that will be negative 1 over 2 will become 1 over 2. And again, your book might say that that's the answer, but remember this you could write as a radical. So it would be the same thing as the square root of x plus 4. So it's okay if you box this in, or you could write it as the square root of x plus 4. Now, you would want to look at these two and say, could we factor by inspection? But you would not be able to. You wouldn't be able to get two numbers that multiply to 18 and sum to 8. Okay, same with this one. You wouldn't be able to get two numbers that multiply to 14 and sum to 8. So these two cannot be further factored, which leaves that as our answer. Okay, what I want you to do for this would be our standard of excellence, and then in the homework there's one really good standard of excellence. Um, I want you to look at just the numerator. So I've got a 2x minus 5 and a 2x minus 5. So what I could do within this numerator is I could factor out a 2x minus 5. And I'm going to factor out the 2x minus 5 with the smallest exponent. So I'm going to factor out a 2x minus 5 to the negative 1/2. So what I want you to do is just sort of ignore this denominator, and let's just focus on that numerator and factor out, factor from the numerator. So what I'm going to do is I'm just going to rewrite this, the numerator, 2x minus 5 to the 1/2 plus 4, 2x minus 5 to the negative 1/2. So what I could factor by a GCF from here would be 2x minus 5 is what's common to both terms, and factor out the smallest exponent, which would be negative 1/2. So my numerator, the GCF, was that 2x minus 5 to the power of negative 1/2. Now, when you factor out that numerator, or sorry, that GCF, let's see what we have remaining. So on this side, we're going to have 2x minus 5. We got to figure out what the new exponent is going to be. So we're going to have 2x minus 5. So I need to subtract 1/2 minus minus 1/2. So 1/2 minus this, right? So it's the top exponent, this is quotient law, minus the bottom exponent. That will give me 2/2, which is 1. So it's nice. So this is to the power of 1, which means I don't even need that bracket. Then we had, what did we have? We have a plus. This will cancel. So when you have the same exponent, it will cancel, and I've got a 4 left over. Now this will clean up because this is 2x minus 5 plus 4. So I'll bring my like terms together, and that would be 2x minus 1. Now remember, this was my GCF to the negative 1/2. So what I have is that's my numerator factored, and that numerator is all over the denominator of 2x minus 1. So the denominator is 2x minus 1. Now hopefully you could see that 2x minus 1 and 2x minus 1 would cancel. What I'd be left with from here is I'd be left with 2x minus 5 to the negative 1/2. I'm going to reciprocate that to get 2x minus 5 to the 1/2. And then, again, your book will stop there, but you could take it one step further and say that's the square root of 2x minus 5. Okay? Let's do two additional questions that I really like. So I tell you to factor this. You got an x, we've got no x here, and we've got x to the negative 1. So the clue should be, I mean, we always factor out the smallest exponent, which is an x to the negative 1, but this doesn't have an x. Rewrite this so that you could put an x here, because we could put an invisible x there, right? So we have an x plus 5x to the 0, right? There would be an x to the 0 there because anything to the power of 0 is 1. And then plus 6x to the negative 1. You want to factor out your, now I've got x in all three terms, and now I could factor out an x. You factor out the x with the smallest exponent, which is going to be an x to the negative 1. That will be my GCF. So x to the negative 1, x to the negative 1, x to the negative 1. Okay, so that gets factored out. And what I have is I've got x1 minus minus 1. That's going to give me x squared plus, over here, I've got 0 minus minus 1. That's going to give me 5x plus, this will cancel, and I'll have a 6. Then you do want to look at this, and you want to say, can this be factored? This could be factored by inspection. Two numbers that multiply to 6 and sum to 5. So for this one, we've got 2 and 3. X plus 2, x plus 3. And then there is an x to the negative 1 in front, but I'm going to reciprocate that, and I'm going to bring that x to the denominator to make it positive. Okay, so that would be my answer for that one. Let's do one similar to this one. So you look at this and you say, okay, we haven't done one that looks like this, but make it look like, rewrite this question so that it looks like this. So for example, if I reciprocate this and I bring that x up, it becomes x to the negative 3. Plus, I want to reciprocate this, bring that x up, and it would be to the negative 4. Minus 24, again, reciprocate, and you're going to get x to the negative 5. Now it looks more familiar. So I've got an x in each term, which means I could factor out the x with the smallest exponent, which is going to be the x to the 5, negative 5, sorry. Okay, so that goes in front of your bracket, and your answer goes in the bracket. So negative 3 minus negative 5. Negative 3 minus negative 5 is negative 3 plus 5. That is x squared. Plus 5. And figure out what the exponent on this x would be. So negative 4 minus minus 5 would be x to the 1, which I don't need to put, minus 24, because this will cancel. Then we're going to look at this, and we are going to say, could we factor by inspection? Are there two numbers that multiply to negative 24 and sum to 5? And that would be 8 and 3. So 8 and negative 3. And then I'm going to bring the x down and write it as a positive exponent. Okay, so that is the first lesson in pre-calculus. And your homework for this lesson, you might have already done 1 and 2 from the textbook questions. So again, this is your textbook work. You'll now be able to do 4A, B, and F. So 4A, B, and F. And actually looking at this, do E as well, right? So just put an x to the 0 here, and then you'll be able to factor out x to the negative 2. So let's add that one. When you picked up your note package for this unit, you would have also been given a homework package. So these two are in the handout. So lesson 1, I'll just quickly show you the handout. The handout looks like this. So this was lesson 1, and this is lesson 2. And so just do the questions that I assigned. So do 1, 2, 3, 4, 5 from question number 1, and then do these ones from questions 2 and 3. Okay, so this was your handout. C is the standard of excellence. So C is like the AP standard of excellence question. And then when you're done that, you could start lesson 2.